Hello everyone, this is Shubham Divakar over here and I welcome you all to the series wherein we solve daily LeetCode questions, and it's been a long while. I have not been solving these questions, but today I have a very easy question to solve, but since this is a very fundamental question related to dynamic programming and recursion, so I'm going to solve this right now. Okay, the question is climbing stairs. It says you are climbing a staircase. It takes n steps to reach to the top. Okay, so each time you can either climb one or two steps. Okay, so you can either take one step or you can only take two steps. Okay, so either one step or directly cross over two steps. So in how many distinct ways you can climb to the top? So we have some sample examples. Let's take for three, which means if you have three steps, so you can climb in how many ways? Like you can climb in three ways. So it could be 1 1 1 1 2 or 2 1. All right, so let's see how we can decode this part. Okay, so let's get ahead and let's first check for n equal to 3 only. Okay, so let's say we have three steps. This is the first step, second step, this is the third step. Okay, this is 3, this is 2, this is 1. So starting from here, if I take only one step, so I can go over here and then go over here. So taking only one step, okay, so I have one more step over here, like this is base 0, so we're starting from here. Okay, so taking one step only, so I can go in this way. Okay, one thing we can note from here is that, see, we are not asked to find the most optimal or the shortest step way. We simply have to find the total possible ways by taking one step at a time, or a combination of one or two, or only two steps at a time. Okay, so now what are we going to do is, now we will try another thing. Okay, so what we are going to do, we will take one step to here. Okay, and then we can take two steps from here directly, because we are allowed to take either one or two steps at a time. All right, so that will also be counting to 3, so 1 plus 2 is one more option. Or if I can take one step, okay, one we have already taken, right? So if I can directly go from here to two step to here and then one step to the last one, so that would be what, 2 plus 1. We cannot take two steps from here because that would exceed 3. All right, so if I had to decode this, okay, how could I decode this and write a program with this? Okay, so let's say you have to create a number 4. Now how can you create it? By using only 1 or 2 starting from 0. So I have two options, either I'll add 1 or either I'll add 2. So if I add 1, this will become 1. If I add 2, this will become 2. Now again here I have two options. If in 1 I add 1, that will come to 2, and if in 2 I add 1, that will come to 3. Now here also I have two options, and what are the two options that I have? If this can become 3, this can become 4. Okay, by taking only 1 or 2. Okay, now again this 2 can be, again we have two options. So 2 plus 1 is 3 over here, and 2 plus 2 is 4 over here. Now again this 3 we can go into it, like we can take 1 or 2. If I take 1, this will be 4, and if I take 2, this will be 5, which is not acceptable. So we cannot take this part, right? So I have to erase this part. I cannot take the second part over here. Okay, now again this 3, same thing will happen. I have to take 1, that will 4. If I take 2, this will be 5, which is clearly not acceptable. So I am going to erase this part. Now again with 4, okay, so we have already reached 4 over here, so we need to move further. Here also we have 4, but here we do not have 4. Okay, so 3, again we have two options here, 1 or 2. So 1 will get to me 4 and 2 will get me 5. So this is not option, I mean this is not required, we cannot cross that. So we have reached. So how many ways do we take to reach this part? Like, see, this is one way. Like if I start from here, this is one way, this is second way, this 4310 is third way, this is fourth way, and this is fifth way. So clearly we can see that starting from 0th step, we can reach to 4th step in how many? In 5 number of ways. Okay, so if I had to start from the bottom part, okay, now we started from top part. Okay, now let's start from the bottom part and see what changes can we, what significant thing we can observe. Let's try first that part. I have 4. Now this 4 can be made, we have only two options to reach. I mean we have whatever the step is, like 4 can be made by using only two numbers, because that is what the constraint of the question over here is, by 1 or 2. So I need to subtract this, like this will be 3 and this will be 2. Now this 3 can be made by using 1 or by using 2. If I reduce 1, that would be 2. If I reduce 2, that would be 1. Again, I have two options over here. Now this 2 can be made from 1 by adding 1, and this 2 can be made from 0 by adding 2. Okay, so now again this 2. Now see, one thing we can also observe here. Okay, first let's get to this 2. So again I have two options, 1 and 2. This is 1, this is 0. We can see that this part, it's very similar to this part. Okay, now why I'm trying to tell you is that because see, when we are doing this, like here also we had a repetition, like this entire 2 3 4 part is coming here also. Okay, so this is a very vital, these are very vital, okay, changes, I mean not changes, but these are very vital things we need to take here, because we can skip this part, right? We did not need to compute. So look, let's first stick to recursion part, okay, and then we'll code this down. So this 1 can be further reduced by 1 or 2. So this is already 1. 1 can only be reached through 1 from 0th step, and if we reduce this will not be acceptable. Again, this 1 part will only be reached through 0th part. Alright, so we can clearly see we have how many parts? 1 way, 2 way, 3, 4, and then we have 5. So clearly again we have 5 ways, and here we are building from the top. Alright, here we were building from, like if I consider 4 as the top, so this is we are building from the top, and if I consider 0 as the bottom, this is the bottom up approach. Alright, now the thing here is, for every n, like now we need to think for n. Okay, so like for every n I'll have only two options, either n minus 1 or n minus 2, and number of ways to reach this n minus 1 plus the number of ways to reach this n minus 2 will be the number of ways to reach n. Okay, so say clearly how can I say this for this 4. Okay, 4 is, let's say we have 4, so number of ways to create 4 is 1 plus, or number of ways we can create 3 and 2. So how many ways we can create 3? See, this 3 can be created by 1 2, this one approach is there, second approach is there, third approach is there. So 3 can be created in total 3 number of ways. Now this 2 can be created in 1 way and 2 ways. So this is, and the sum of these two is the total number of ways. Okay, so clearly we can see that we can reach this n minus 1 and n minus 2, the total number of ways of reaching these two, and the summation of that would be the number of ways to reach this n. Alright, so if I were to code this down, alright, how would I code this down? We can see that this is clearly recursion, because each part is dependent upon the previous part, because 4 is dependent upon 3 and 2, now 3 is dependent upon 2 and 1, okay, and 2 is dependent upon 1 and 0, here also the same thing, right? Let's code that down first. Okay, now what would be the base case over? The base case here over here is that if at any point of time I reach 1, I need not need to go for 0, because 1 can only be reached from 0 in only one number of ways. Like from 0 we can go to 1 by using 1. Alright, so that is the base case over here. So if n is less than or equal to 1, you simply need to return 1. Alright, and what we need to again check for, like if I had 4 over there, I had to check for another n minus 1 and n minus 2 ways. Okay, like I'll tell you what I have to write it down over here and why I am doing this. See, okay, for 4, let's say this is 4, so 4 is dependent upon 3 and 2. Okay, so 4 can be reached in how many ways? The number of ways we can reach 3 and 2, summation of these two parts, and for each and every n we have to do this until and unless the value is equal to 1. So when it is equal to 1, we will return 1 over here. Okay, and we will return 1 over here, and we'll keep on returning these values. All right, okay, cool. So now let's code this down. So clearly we saw that for 4 we had 3 and 2 as options. So for n we would always have to go through n minus 1 and n minus 2 number of ways. Okay, so let's run and check this, what happens. See, I clearly solved this earlier, so this is what it is for. Let's check what happens now. Okay, so it runs. Now let's submit and check. We have a very interesting conclusion we will draw from here. Okay, So this shows TLE, last executed input was 45. Okay, now why this TLE is there and how we can avoid it, that is also a very interesting thing. Okay, as I was telling you, to take care of certain situations, like see, I'll erase this part again and we will go for n equal to 4 again. Okay, and what is the correct approach of solving this question is that also I'll tell you. So let's say we had this 4. Now according to our question we will be splitting this into 3 and 2, because this is 1, this is 2. So again 3 can be derived from 3 minus 1 is 2, 3 minus 2 is 1. Now this 2 can be derived in, this is 1, this is 0. Okay, all right, so cool. This 2 can again be derived using 1 and 0. This 1 can be derived from 0 itself, and this 1 will be derived from 0 itself. Okay, now if I start from 4 again and see what are the things we are repeating. So at one step we are reducing 4 to 3 and 2. Okay, the second step we have reduced 3 to 2 and 1, and at the same time we have reduced 2 to 1 and 0. So okay, so we can clearly see this 2 1 0 part, this is being repeated over here. Okay, like this one will be also be reduced to 0. All right, so these two parts have been repeated, and these are the reasons why TLE is there, because we did not need to calculate this 2 again. For this n minus 1 we are already calculating. So when we are crossing this 3 we will be reducing to n minus 1, 2 and 1. We did not need to recalculate this again and again. That is why this TLE is there. We simply need to catch this or store this so that we can reuse this. All right, so if we had somewhere stored like for n minus 2, or for like let's say the function f is here, like if we had stored the value somewhere, something is wrong, yeah. So let's say we had a function f that is storing the value of f of 2, f of 1 and everything. If let's say f of 2 is what, how many ways we can reach 2. Okay, so from here I had already reached like 1 can be reached from 0. So this is 1 way, this is 2 way, this is 2. So okay, so by the time we get 3 we had already calculated this f of 2, and next time when we come to this 2 we did not need to calculate this. We will simply store or get the value from the previous values, or since this is already being stored, so we need not need to calculate this and again. So that is how our TLE will be reduced, because we are again calculating this a further step. So this can be reduced over here. All right, so what can we do? We can simply store the values previously. Okay, the previous values, because see what is happening is each value is dependent upon the previous values itself. Like okay, this is the like 4, we are starting from 4 over here. Okay, so what will happen is we have to store how many, like we have to create 4. So how many ways by which we can create 4 is will be dependent upon 3 and 2. Now how many ways we can get these 2 is dependent upon the previous values. How many ways by which we can create 0? 0 is the base case, so f of 0 we have to put something, f of 1 we have to put something, because f of 1 will always at any point of time will be equal to 1. So whenever we encounter 1 we simply have to return 1, and from here also whenever we get f of 0 that will also be equal to 1. Okay, why I am telling is, see, when I am reaching, like let's say the question is n equal to 1 step. Okay, so this is just 1 step, like this is the 0th step and this is the 1th step. All right, first, so how many ways I can reach over here? So from 0 I can reach 1 by using 1 step. All right, so this is why I have pulled it up over here. Okay, now why this f of 0 equal to 1 has been put up, because from 0 we can directly climb to the second step. All right, by 1 way. So that is also a way. So that is for this very reason I put here. These two are the base cases that we need to hold over here. All right, these two are the base cases that we need to hold over here. All right, and using these two we can compute the other ones. Okay, instead of going from top to bottom we will start calculating from 0 to upwards. All right, since f of 0, f of 1 has already been calculated, let's check for f equal to 2. F equal to 2 can be done in how many ways? Like the using a previous recurrence relation that we had was f of n minus 1, that is f of 2 minus 1 is f of 1 plus f of 2 minus 2, that is f of 0. So f of 1 plus f of 0, f of 1 is 1, plus f of 0 is also 1. So 2 can be computed in two number of ways. Let's check for f equal to 3 now. F equal to 3 can be reached in how many? Like f of 3 minus 1 is 2 plus f of 3 minus 2 is 1. So f of 2 is clearly, we have pre-calculated that to be 2. This will be 2 plus f of 1 is 1. So 3 can be formed in 3 number of ways. And we can check over here, like 3 can be formed in 3 number of ways. That's correct. Alright, this is what we are going to do. We are simply going to catch these two values, and this is nothing but dynamic problem. This is nothing but dynamic programming. It's a very fundamental concept related to solving dynamic programming questions, right? It's a very fundamental problem, and I hope this is very much clear. So same thing, we are going to code it up. Okay, so whenever n is less than or equal to 1, we'll return 1. Okay, this is the base case that we have. Alright, so this will stick as it is. Let's create a dp array, new int, and we'll start from dp of 0. dp of 0 can be formed in one way. Dp of 1 we have thought to be putting in 1, and now we will simply run a loop from int I equal to 2, I less than equal to n, I plus plus, and each state dp of I is equal to dp of something. And what are these two values? These two values are nothing but the recurrence relation that we had. Alright, the previous values. Okay, now the thing is, since we have converted this into dynamic programming approach, and see what happens is, when you are coding dp from recursion, the parameter for recursion was n earlier, and now we have shifted that to dynamic problem. So the state of the dp will now become the variable which was, or the parameter which was the parameter for a recursive problem, and that was n, and we have replaced that to be I. So this is what it is now, right? And here we will simply return dp of n. Let's run and check. Okay, so for 2 it's 2. Let's now compile, run and check. Okay, so it's accepted. So guys, this is it. We have solved this, and guys, please stay tuned to our channel. Please like, share and subscribe. Thank you guys. Thank you for watching.